So the question asks about what the angular momentum vector for a 2 kilogram and 4 centimeter diameter rotating disk is that we can see in this figure. And we know that it's rotating like this over the x-axis at 600 RPM. And basically, the question wants us to show basically the values of each vector here. And there are a few big ideas with this specific problem. And one of the ideas is the idea of rotational momentum, which is very similar to linear momentum, except with basically units and variables of rotation. And the other big idea is the idea of vectors, which really come into play in this question. So to solve this problem, we basically need to use the right-hand rule. And looking at the previous picture, it was going this way. On the x-axis, meaning it was going into the x-axis. So it is, that specific vector is negative in the negative x direction with no other rotation, meaning basically all the other directions, ly, lz equals 0. Um, so the first thing we need to do is we need to convert units. So right now we have rotations per minute, and we can do a little bit of dimensional analysis here to convert some units and then get the final result of 20 pi radians a second. Now using this, we can basically use this as the omega value. We know that for this specific shape, the L, basically angular momentum, is going to be the moment of inertia multiplied by radians per second. This means that we can multiply things out here, 1/2 times 2, which is the mass, times 0.02 uh, meters squared, and then we multiply this by 20 pi. And this essentially makes it so that we get the angular angular momentum here. So our angular momentum in the x direction specifically is minus 0.025, while the other two are 0 because basically there's nothing in those directions. So there are a few common mistakes with this problem. One of the easiest common mistakes to make is not doing unit conversions correctly. The other big mistake here is not separating things out into vectors. So you need to separate basically the x vector, the y vector, the z vector. That's super important. If you don't do that, then basically your answer is not correct. All right, thank you.